Hello everyone, this is Justin. I hope everyone's doing great. Hopefully your first exam went pretty well. Today I'll be going and go ahead and walking you guys through chapter 10, part 1, practice problems. Like always, if you have any questions regarding my walkthrough process or anything like that, feel free to contact me through my email or just go ahead and visit me through my open hours through as well. But yeah, let's go ahead and get started with it. So in this case here for number 1, it's asking us to solve for x. For most of the points here, it should be kind of review, but if not, don't worry. It's relatively easy to find every step here. So let's go ahead and get started. So start for solve for 1. So for part A, since we are going to be solving for that x, what I like to just do is obviously we want to get the same variables on each side. So in this case here, we have x and 3x and 4 on one side. So let's go ahead and just get 4 on the other side by subtracting since it's positive. So in this case, we just get it canceled. And then here, we would just get, since we are going to be, we can go ahead and combine these two as well. So it would just be 4x equals to 8 minus 4, 4. And now what we do, we have 4x equals to 4. So now what we do, since we are solving for x, we just divide that 4 on both sides. This will cancel out, so this will give us x equals 1. So that is the answer for part A. Hopefully that wasn't too quick and too bad for you guys. Just go ahead and just, like I mentioned, combine and try to get each exponent on each side, and that'll just make your life easier here as well. So for part B, this one is a little bit different, but same concept. So this one's going to be 5 with parentheses and x plus 3 equals to 25. So in this case here, I don't know how you guys were taught, but in my case, whenever we have a number that correlates with the parentheses, what we do is something called like a waterfall or a rainbow, totally up to you. You would just multiply 5 with the x and then 5 with the 3. So in this case here, 5 times x would just simply be 5x, and then 5 times 3, since it's positive, it would just be plus 15, equals to 25. So that's how you kind of get rid of that parentheses here. So remember, we want to do everything in order of PEMDAS, which is parentheses, exponents, multiplication, division, addition, and lastly subtraction. So in this case here, since we want to get the exponent by itself, we're just going to go ahead and subtract 15 on both sides. This will cancel out. So then this will give us 5x is equal to 25 minus 15, 10. So now since we are solving for x, we just go ahead, same thing, just get the x by itself. So we divide that by 5, divide this side, this one cancel out. So your answer for part B would be x equals 2. Not too bad so far, right? Yeah, that's really how you're going to be solving for part 1. Simple math there. Moving on to question number 2. Same kind of concepts, but in this case, it's just worded differently. We are giving the variables of what each exponent is stand for and what it is for. So in this case here, I'll actually just write it all through. So we are in the, at the end, just solving for x. So same process. So for part A, it's going to be x equals 2. And then what is A equal to? It's already given me here, which is 15. So be 15 minus what's B. It'll be 3. So 15 minus 3 squared divided by 10. So what are the steps here? So remember, we want to go ahead and use PEMDAS. So what's first? Parentheses. So in this case here, it'd just be x equals 2 to the 15 minus 3, 12 second power over 10. Now what's the next step after this? PEMDAS, exponents. So in this case here, you just kind of get these two here. So it'd just be x equals to 2, 12 to the second power, 12 times 12, 144 over 10. Now what you can do is you can just go ahead and multiply these two here, which should give you In this case here, it'd be x equals 288 over 10. Now you just simply solve for that. 288 divided by 10, which would give you your answer of x equals 28.8. So that is for question number, or 2, part A. So you would get x equals 28.8. I know this probably took up like whole time, but it's okay. We can figure this out. So now for part B, I'll just go ahead and make sure you guys got that down. I'll just go ahead and erase that here. Now I can just give myself some space. So I'll go ahead and leave that there. That way you have it for reference. So part B is same thing. We just go ahead and first start off by filling in what our exponents are. So x equals 2. This one might seem a little bit confusing just because of all the parentheses that are involved here, but worry not, it's the same process, just take it step by step. So 2 with a minus b, same thing as first one, so it'd be 15 minus 3 plus 3 times 3 minus 5, so that's one parentheses. Now this is going to be all over t. So this is a new one. T is equivalent to 4 plus b, 3. So for this case here, it'd just be simply x equals, so let's just go ahead and start off by doing the parentheses first, follow for whatever is in parentheses. So in this case, let's just do 2 times 15 minus 3 was 12. Plus 3 times 3 times 5 over 7. So in this case here, what we're going to do next is we can just go ahead and in the order left to right. So within the parentheses, so remember we're looking at the parentheses first, and then we'll go ahead and break it out to whatever is after. So let's just start from left to right. So in this case, it'd just be x equals 2 times 12, 24, plus 3 times 3, 9, minus 5, over 7. So now we just still keep processing, keep working from our parentheses. So this will give us 24 plus 9, which is 33, minus 5, 28. So 28 over 7. Now you just simply divide that. 28 over 7 gives us a nice even number, and x equals 4. So this would be the answer for part B for the second equation. Hopefully that made relatively sense. So yeah, just given the underlining point here is just work your way up step by step. Do order the follow of order the operations, which is PEMDAS, and you'll be okay with these types of questions here. All right. Let's go ahead and move on with question number 3. So using the following formula to compute the desired quantity, this is going to be the formula that we're going to be using here today to put it. So same thing as question number 2, it gives us the value for the exponents. We just got to go ahead and plug this into the equation. So question number 3, part A. So it's asking if v is equal to 5, t is equal to 2, and a equal to 10, what is d? So in this case here, we're solving for this. So we're going to go ahead and have that blank. So d equals to v, which is 5. T is 2, so over 2. Plus 1 half. Times a, which is 10. Times t, which is 2. Squared. Okay, so in this case here, same thing, order of operations. So let's just start off with our exponent. So 2 by 2, which is going to be 4. I mean, if you guys know, you can go ahead and just, I mean, start multiplying these exponents, but I just go ahead for the sake of it. I'm just going to go ahead and walk you guys through within order in case you do make many mistakes. So in this case here, since we all have it nice and got rid of our exponents, now we can go ahead and start by multiplying our values. So in this case here, d is equal to 5 times 2, which is 10. 1/2 times 10, same thing as, sometimes I like to just, if it's 1/2, I just go ahead and make it easier. Just make it like in the decimal points. That way I can visualize it better. Same value, you just change it differently. So 1/2 times 10, which would give us 5. So plus 5 times 4, which will give us d equals 10 plus 5 times 4, 20. So now we just add last ones. D is equal to 10 plus 20, which was 30. So this is the answer for part A, which is D. D is equal to 30 in this case here. Same exact process for part B. In this case here, now we're just trying to find what is V. So we're already given what D is, so D is equal to 80. So we just plug that into our equation. 80 equal to V, which is, so that's what we're going to be finding here today, V. So we just go ahead and leave that blank. V times T, which is given here, 2, plus 1/2 times A, which is 10, times T, which is 2 squared. So same thing, we can go ahead and just keep going with this here. So just go ahead and follow your exponents. So 80 is equal to 2V. And just keep that there. Plus 1/2 10 times 4. So in this case here, we can go ahead and start off by multiplying the last part. So 1/2 times 10, which is 5. 5 times 4, which would be 20. Let's plug that in just in case. So 80 is equal to anything plus 20. So in this case here, we're just going to go ahead and simply just subtract 20 since we're going to try to get V by itself. Subtract 20 to both sides. This will cancel out. This will give us V squared, V to the times 60. So how do we get this by itself? Since we are trying to find for V, we just simply divide. Since it's multiplying, we just go ahead and cancel it out by dividing. So divided by 2, this will cancel out, which will give us the underlining V is equal to 30. So in this case here, coincidentally, it's 30 as well. Just different method to find it. It's just going to be the exact same right there. Hopefully that does make sense for you guys. All right. Moving on forward with question number 4. So this one is asking us, a football is kicked with a velocity consisting of a vertical component of 12 meters per second and a horizontal component of 6 meters per second. So question part A is asking us what is the resultant velocity. So remember what that means is we are trying to find the velocity for all points given sides. So in this case here, we'd be using the Pythagorean theorem formula. So it'd just be simply a squared plus b squared equals c squared. So now we just plug in our values here. Remember, we always want to, so if it makes you visualize better, this would be A, B, it doesn't matter which order it has to be. We just got to know, I guess the important part of this is C is always going to represent your hypotenuse. So in this case here, we just go ahead and use that. So we do C, so it would be 6 squared plus 12 squared equals C squared. Or V squared, since we're trying to find the velocity. It doesn't, I mean, You can put v squared if it helps you realize what you're kind of trying to look for, but I'll just, for the sake of it, I'll just go ahead and keep that. So now you just plug it into your problem. So 6 squared is 36, 6 times 6. 12 squared, 12 times 2 is 144. 2c squared, so now you just go ahead and add 36 to 144, which would give you a value of 180 equal to c squared. How do we get a squared by itself? We just go ahead and simply just square root it. So this will cancel out. So that would mean c is equivalent to when we get it, it's be 13.42 or 41. Let's keep it at 41. 13.41 meters per squared. And that would be our answer for the resultant velocity. So we just go ahead and change that to v since we know we're given. So that would be the answer to find for part A. So this one would be 13.41 meters per second. For part B, now it's asking what is the angle of release with the horizontal. So remember, it's asking with respect to horizontal. So in this case here, we're going to be using what is our horizontal velocity. So in this case, well, actually, let me go ahead and rephrase that. We always want to use what is given. So in this case here, since we are trying to kind of find with respect to the horizontal velocity, this would be where our angle is, what we're going to be looking at. So in this case here, same thing in this one in case for 6 meters, it would be 6 meters per second, sorry. This would be our adjacent side. And then 12 meters per second would be our opposite side. So remember what I mentioned, we always want to use what is given, just because if we use the other one, it'll just make your life more difficult. So in this case here, opposite over adjacent, what would that kind of sound like? SOHCAHTOA, or sine, cosine, or tangent. So in this case here, TOA, opposite over adjacent. So we're going to be using tangent. So in this case here, since we are not giving the angle, what we'd be doing is, let's just go ahead and write it up here. Tangent of angle is equal to obviously opposite over adjacent. So in our case, right here, the opposite would be 12, so it'd be tangent degrees over 12 over 6. So in this case here, since we are finding for angle, we want to go ahead and get that by itself. So how we do that by itself, we just go ahead and divide tangent to both sides. When doing that, it does change up your tangent. So in this case here, the angle would be now, so whenever you do move it over tangent or cosine or sine to the other side, we just want to go ahead and change it to tangent to the -1 power. Now 12 over 6. So in this case here, when you do plug it into your calculator, it always or usually like in the calculators, there's already going to be a sine, cosine, tangent button, but in this case, most of the cases, you just go ahead and second it to the power, and now it will give you that tangent of -1, and you just simply just plug in your values, which is 12 divided by 6, which would give you a value of a degree of 63.43. So that is going to be the answer for part B, which is the angle of release with the respect of the horizontal. Alrighty. Okay, so moving on to question number 5. This question is asking us, a shot putter puts the shot with an initial velocity of 25 meters per second. So I'll go ahead and underline that since we know what the initial velocity is, at an angle of 32 degrees. So that's another important detail we need to add, from the right horizontal. So part A is asking us what is the initial horizontal velocity of the shot. So if we think about horizontal velocity, obviously it's given, it's asking for the horizontal plane. So in this case here, we're going to be looking for x. So let's go ahead and put that there. So for this here, since we are looking for x and we are given the angle, and I mean technically this would be considered our hypotenuse. So this would be, so in this case here, this would be our adjacent side and our opposite side since it's related to the angle of degrees here. So since we know we're looking for our adjacent and our hypotenuse, if we go alongside with SOHCAHTOA again, SOHCAH, and we're going to be cosine is with adjacent and hypotenuse. So in this case here, we're just going to have cosine of 32 degrees is equal to, since we don't have x, we're just going to go ahead and leave that blank. We can either put like v of x since we know we're looking for the velocity, or just keep it as x, just something to initiate, to let you know what you're doing. And then the below one is going to be 25. So in this case here, we want to go ahead and get rid of or kind of get v of x by itself. So in this case here, what we would do is, since it's division, we would just simply multiply for both sides. So this will cancel out. So now it would just be v of x is equal to 25 times cosine 32. So now once we plug that into our calculator, this would give us the answer of, so it'd be 25 times cosine of 32 degrees, would give us a horizontal velocity of 21.20 meters per second. So that would be the initial horizontal velocity for part 5. Now when we're talking about, we would do the exact same process for part B, but now in this case here, we would be looking for vertical velocity. So in this case, it would be y. So in the case of finding vertical velocity, we're going based off where the angle is. So since we are given the hypotenuse, always go with what's given the hypotenuse, because let's just say, for example, I mean, same thing as the other one. If we go based off what we found here and we got this one answer wrong, that'll just already give us a wrong answer for part B. But if we do what's already given, it might give us a slighter bit better chance to get part B at least correct. So in this case here, since we are looking for vertical velocity, since we know from the degree y would be considered the opposite over hypotenuse, so opposite over hypotenuse. So in this case, instead of cosine, it would be sine of 32 is equal to, since we know same thing, v of y over the hypotenuse, which is 25. Same process, we would just multiply from each side to get v of y just individually on the other side. So v of y would be 25 times cosine of 25. Cosine 32. So once we do that, we would just multiply this. So once we get that, we would get an answer of, and the vertical velocity is equivalent to 13.25 meters per second. So that would be the answer for part B. Relatively simple, kind of following what we did with there. So moving on to question number 6. Now in this case here, same thing, just more practice on finding initial horizontal and vertical velocity. So we would just go ahead and do the exact same process. So for question number 6, same thing. So let's just go ahead and start with part A, since it's asking for the horizontal velocity. We know with horizontal, it's going to be equivalent to finding with cosine, since we are doing adjacent over opposite. So in this case here, it would be cosine 25 equal to v of x over 12 over the hypotenuse. So remember, we would just go ahead and multiply 12 on each side to get the velocity alone. So v of x would be 12 times cosine 25. So we just go ahead and add that to our calculator. So that would give us a initial horizontal velocity of 10.88 meters per second. So that would be the answer for part A for regarding of finding horizontal velocity. Same process for the question above. For part B, you would go ahead, since we're looking for opposite and we are giving the hypotenuse, so so it'd be sine. So this one would be sine 32 is equal to v of y over 12. Same process as when we did. Try to get this alone. So this will give us v of y is equal to 12 times sine 32. So this will give us an initial vertical velocity of 5.07 meters per second. Okay. Moving forward, lastly, for question number 7, this one is asking us the velocity of a long jumper during takeoff at an angle of 30 degrees is 16 meters per second. So remember the takeoff, this one, when it's asking, so we know 16 meters per second is the velocity of the long jumper during takeoff, we would automatically assume that would be the hypotenuse. So that's why this one's here. Since we know the angle, this would be the angle, so that's why it's given 30. So question number A is asking us how fast are they moving forward. So during your exam, obviously this is going to be, sometimes it's going to be worded like this, and obviously you won't be you would have to think a little bit more instead of just asking for horizontal or vertical velocity. It'd be asking you something more so applicable in real life situations here. So how fast are they moving forward? So since we know forward is kind of moving in the horizontal plane, we kind of just noted here would be focusing, same thing as asking the question above, what is the initial horizontal velocity? So same thing process, we will do the exact same process. Only difference here is that it is worded differently. So for part A, since we know the horizontal velocity is looking for x, this one is going to be looking for cosine. So cosine of 30 degrees is equal to v of x over 16. Same exact process. We would just multiply 16 on each side. Once we do that, we would get v of x is equal to 16 multiplied by cosine of 30. Once we do that, we would get a velocity of 13.86 meters per second. So that would be the answer for question part A for question number 7. Now for question B, this one is asking us how fast are they moving upwards. So in relative here, it's going to be looking at the vertical component. So in this case here, we'd just be looking for y. So right here, since we are looking for y, it would just be the exact same process. SOHCAHTOA, we are now looking at sine since it is opposite over hypotenuse. So it'd be sine of 30 is equal to v of y over 16. Same process, just multiply 16 on each side. So this would be v of y, 16, 30. So this would just give us a vertical velocity of exactly 8 meters per second. So that is how you solve all these questions for this part of the right here. If you have any questions regarding the process steps or any clarifications you need, like I said, feel free to email me or contact me. And yeah, hope you guys stay well and have a good one.